take our belt, which shouldn't lay all the way down in the groove yet. Oh yeah, that looks nice in there. Perfect. This package comes to us from Bob at the Bison Workshop. And this is a ream that I sent him. And this is a pulley I need to have duplicated. And it's all here, still in good shape. Here's something you made. Let's set that aside. What do we have here? Wow. So this is a brass hammerhead. Brass hammer that he sent me. Is it brass or steel? No, it's not steel. Boy, it's got some unusual coloring there. Yeah, it definitely looks like brass on this side. Looks like, I don't know what on this side. USA. Bummery, 1.5 pound. Made in USA. So cool. American hammerhead. So I need to make a handle for this. I might have a handle, actually. Cool. Set that aside. This is a arbor that you use for turning things between centers. I think I know what this is. We were talking about whether or not this might be a machinist level. I don't own a machinist level. He got a couple of them in a deal. Yeah, I would say that's what it is. Looks like it can be calibrated. There's a spring. That's a loop on the end of the glass vial. And here's the wrench for adjusting it. So obviously, this cannot be used until it's calibrated. What's interesting about these calibrations is you could do a relative level on something. You could level a machine, you could level a lathe to, one corner of the bed by turning the dial here and zeroing this out, and then moving it around the lathe and adjusting the different feet until it was all the same. Because more important than level is that it's all relative, so there's no twist in the bed. So that's a cool tool. Didn't own one of those. Looks very sensitive. It's got 3 lines on it. I'll have to read about this, make sure I understand. Those lines may be calibrated to indicate some specific, a minute or 5 minutes or a degree or something. There's my metal. Man, I got to get my cutoff saw working. So let's look at this pulley. Very interesting. I think this is a mark from trying to push the big end in. Go clean that up with the ream. Got all the grip I got. Boy, this end's small for some reason. Yeah, I don't think this can be finished into a pulley. I don't know. Let me measure it here. Let's see, that is supposed to be 395, and in the middle. So we got 200 thousandths on the wall. Yeah, so this groove can be finished. This groove's a little thin. Yeah, I think a pulley can be finished out of this. You might have gotten frustrated with yourself a little too early. I don't know. Hate to see the piece of metal go to waste. Yeah, we're a little undersized there. Three inches, 335. Yep, a little undersized on both diameters. The grooves could have been finished though, and just for learning purposes, I would love to have seen you finish the finish making the grooves. There's that magnet. Finds everything metal. I'm going to have to go clean the hole out in this. It's just bugging me that that doesn't go through there easily. Alright, after running the ream through it, it'll mount on the mandrel nicely again. Very good. It's a beautiful day outside the shop, finally in Ohio. But inside the shop, we have a job. Here we are set up on the lathe between centers. And some of you may recognize this project. This pulley was scrapped by the original machinist because he thought it had too many and too large errors in it. But I don't think that's the case. It's a pulley. It doesn't have to be that tight. Here's what we're trying to replicate. This is a pulley off of a, I presume, a 30s 9-inch South Bend lathe. And I bought a lathe and sold it to a business friend of mine who needs a lathe in his shop. There's a few things that needs to be correct, and that is one of the things is this pulley. The lathe currently has a just a single groove pulley on it, and it needs to be a double so he can change the speeds. So I need to make him a pulley. These things are about 60 bucks on eBay plus shipping, and we've got a blank here that's most of the way done. We've got a few measurement errors here, and let's go over what they are. Now the part in the lathe is upside down to the drawing, but here's what we were supposed to have. A 395 groove. It's actually 430. Now all that is going to mean, because the groove is 35 thousandths wide, is that the taper won't go in quite as far. So it's really only off about a 64th of an inch per side, which really isn't that bad. No one's going to notice. Let's see. Oh, some other measurements. This groove here is off a little bit. The width of this flange is off a little bit. It's all things that aren't going to make a big difference. We're still going to be able to complete this into a useful pulley and not scrap the part. The diameter of the part is under slightly, and I understand why the machinist got frustrated with it and quit on it. But hey, I think it can be finished. And Bob at the Bison Workshop, he's known for making something out of nothing. So I'm going to take something that he thinks is nothing and try to make something out of it. Try to make a useful pulley. So the first, I'm going to work from this end. The first thing I'm going to do is machine this flange here, and we're going to keep this position as a basis for our pulley. So we're going to machine this and then come over here and machine this side. Right now the flange, the outer flange hasn't been machined down in thickness, so I'll machine that down. And also this flange has not been machined down in thickness, and I can take this back a little bit to get this sidewall correct for this side of the pulley flange here. So that's basically my plan, and let's get to it. I have my compound slide set at 15 degrees so I can cut the inside wall of this. I've got a tool bit in here. I've had to turn this tool at an angle so that my AXA holder here doesn't hit the inside of this flange. I don't think this right front point of the tool is going to hit in the bottom of our groove. So how are we going to proceed? Well, the gap should have been 395, but it's actually 430, the width of that flat space there. At the widest part of the flange, up here at the point of the bevels, it's supposed to be 625. So 430 from 695 is 195. So that means that I have to come back from this edge 195 thousandths and make the 15-degree cut in order to end up with a bevel that's correct on each side. Now, of course, we're working on the small one here. So I'm going to touch off on the inside of the edge of this groove, and I'm going to set my carriage stop, and I'm going to back it up half of the 195 thousandths so that I get, what would that be, like 97 and a half, 98 thousandths a side. So that when I'm cutting this, I only go back that prescribed distance. So let's do that. I've got everything tight, everything installed, never turned between centers in my life. Here we go. So there's a touch off. I'm going to watch this knuckle buster here. Get the carriage stop set. I don't have a set of gauge blocks. The perfect thing to do would be to set this with a set of gauge blocks. If you got an extra set of gauge blocks laying around, email me and I'll tell you where to send them. Here's my solution. I don't own gauge blocks to set that spacing with, but I do own letter number fraction drill bit sets. This is 96 thousandths, 97 and a half would be perfect. This is close enough for a pulley. So I'm going to back off the stop, put the drill bit in there, set the jam nut, And there we go, I have the proper clearance. So now I can't, as long as I don't move this block, I can't cut back too far and ruin the pulley. So I'm taking off 97 thousandths per side. Here we go. So now I'm going to move the carriage a little bit. Still not touching. Move the carriage a little bit. There we go. Move the carriage a little bit. I guess I'm moving the carriage maybe 20 thousandths at a crack. 10 to 20. This is by no means an exhaustive video on how to make a pulley. Those are out there on YouTube. But what I'm showing you how to do is how to take something that's cut a little bit wrong, but close enough, and make something out of it. Okay, I'm all the way to my stop now. Hope that makes a nice finished cut. Let's look at it. I think that looks good enough to be the side of the pulley. Let's take our belt, which shouldn't lay all the way down in the groove yet. Oh yeah, that looks nice in there. Perfect. Yes, I guess I'm going to do the other side of this groove since I've already got my compound set for this angle. And I certainly wouldn't be moving that over any farther since this groove is a little bit too wide anyways. So let's set that up and do it the same way. Loosening my carriage stop. I've decided to go ahead and cut the other side of the small pulley and get the belt fitting there good first. So I have to turn my compound 15 degrees in the other direction. Yes, happy with that. Come in here and touch off on the inside edge of the pulley. There we go. Pull the cross slide out. Now, how do I control this? Let me think about it. Oh, okay, so I'm going to use my carriage stop, but I'm going to put it on the other side.